Well, let me introduce, Taiming Cheng. Taiming Cheng is now professor of Impact of Chinese Politics at it's called GPS, School of Global Policy and Strategy. Formerly it was IRPS, in the School of International Relations and Pacific, Studies. And University of California system has a very interesting, program called the IGCC, Institute of Global Conflict and Cooperation. And now Taiming is the director of the institute. Susan Shep used to be director, but she retired. She's a director emeritus. And Taiming has been running the IGCC, and one of the most important contributions to IGCC is to initiate so-called Northeast Asia Cooperation Dialogue, NISAD. Now, it has lasted now how many years?
NISAD is, it did this 26th meeting last week.
Studied from
93.
93, yeah. I attended the first meeting, and I was teaching at IRPS at the time. And Taiming has done, fortifying China from Cornell, and also prior to that he was a journalist with the Bison Economic Review and covering China, and he has made a lot of important contribution about the commercial activities of the PLA and recently defense industry in China. Most specifically, he has been really making pioneering works and the innovation in defense industry in China. And also, he has got a huge grant from Pentagon, Department of Defense. He has got about $15 million from Pentagon to study, overall military changes and innovations in China. He has been running the program for 9 consecutive years. And in fact, the UC San Diego's IGCC has become kind of a new research center for China, particularly China in the defense sector. With the background, and Taiming will be giving a talk on how innovative Chinese defense science and technology development is very new. In South Korea, we have a very limited access. And we have a very few Chinese who would come and give a talk on the topic.
Well, even in the US, you have very few.
Yeah, and we have been trying to recruit some scholars who can learn China, but very limited. It's very strange, because PLA folks rarely come out, and civilian scholars doing study on the Chinese military is very much limited. We have some exceptions, and there was this background. Let us give a bigger power to Taiming. As I told you, Taiming will be giving about 30-minute presentation out of his PPT, and then Mark DeBurre is professor of political science at St Andrews University in Scotland. He got his PhD from MIT. He's American, but he's loaned out to Scotland. Okay, and he has done a lot of works on aviation industry, and also in the British, the defense industry. But he has been focusing on the aviation industry in comparative perspectives. Therefore, he will give Mark will give about 10-minute comments on the timings, and then we'll open to the floor. Okay.
Okay, thank you, Cheng-In. So, we can do it also, you can all wait until the end, but as I said, this presentation goes on for a very long time. So, and it covers a lot of ground. So, also feel free to ask questions as we go along. My usual answer is, it's in the slides that will follow in a couple longer. It's like, and sometimes it doesn't, but that's my answer, and I'm sticking with it. So the question, how innovative is China's defense science and technology development? This is a very good question, especially because when the Defense Department funds me, I always say, the grant is almost running out. I need another couple of years to be able to answer this question. So can you please continue to extend my grant, because it's a complicated question. It's one of those, it's like you can never really fully answer, because one of the things about looking at China, and especially looking at the Chinese defense science and technology system today, is that there's significant change. When I first studied this issue 10 years ago to today, there's significant transformations that are taking place, and the rate of change is actually speeding up rather than slowing down itself. And this is both in terms of the output as well as the organizational and the types of inputs itself, and how the impact is around the region and the rest of the world itself. So this is a very much of a very fluid picture. But it's so what I'm going to do is to give you sort of like some of the key features of what is going on, and also some of the ways to actually think about that. So as a good academic itself, one of the big questions that I will spend the 29 minutes of the 30-minute presentation is to define what innovation is itself, and then I'll have 1 minute to give you the evidence itself. As an academic, we have to confuse you first before we show you what the light is. So we've disappeared. So this is the classified version, by the way, itself. So I'm just trying to see. So I mean, it's as this sort of emphasizes that over the last couple of decades, especially since the end of the 1990s, China and the Chinese defense industry has been making accelerating progress in its efforts to be moved from like a defense industrial laggard to get to the global frontier. I mean, in the mid to late 1990s, the Chinese defense industry was sort of had its technology levels were roughly like where the global level was back in the 1960s. It was much more like geared to be able to fight a low-tech mechanized war, like of the Vietnam War variation, rather than fighting like the information-intensive technology wars of the 21st century itself. And this was, I mean, so the Chinese defense industry 2 decades ago was in a very, very difficult situation. It was in a deep decline. It was stagnating, and like the leadership in China was extremely worried, especially in the mid to late 1990s. China was facing a very difficult security environment. You had the issue of cross-strait relations with Taiwan. You had the examples of what high-tech wars were with the first Gulf War and what was happening in the former Yugoslavia, etc. And so this galvanized the Chinese authorities to really say, we have to do something about our defense industrial base, because to be like a respected, competitive global military power, if you don't have a defense industry to be able to provide you with the goods that are required by your end users, by the PLA, etc., no one's going to take you seriously itself, and especially your security is seriously compromised. So over the course of the last 2 decades, we have seen like a fundamental effort to overhaul, reconfigure, and develop like a new defense industry out of the foundations of this dilapidated enterprise, and the progress has been extremely significant itself. So when you see what's coming out from an output point of view, it's like the gap has narrowed from, as I said, about 2-3 generations now to perhaps 1 generation or even less in certain areas itself. And so what accounts for that itself? And I'll go into a number of issues of what goes on itself. But first of all, so I promise not to spend too long, what do we mean by innovation and how, so because that's one of the key terms that I'll be using. It's And the Chinese thinking about innovation in general and how it relates to defense innovation is like they have different ways to look at this. And this has a very important way to how we assess the pace of progress. So what I've done is like there's a typology of innovation that it applies to China, but it also applies in general. So I mean, it's like a catch-up, a latecomer catch-up state that China has been and still is, although that's changing, is their model of innovation is what we would define as an absorptive approach, right? Like countries like China or Japan before it caught up in the 1950s and 60s, or South Korea, etc., in the 60s and 70s. When they talked about innovation, it was really about how you absorb foreign technologies and knowledge, and then how you are able to develop it and turn it into your own products itself. And an absorptive model of innovation is very different from real innovation, because absorption emphasizes like engineering, right? Emphasizes like production itself. So like the ways to, so like there's very little focus on research and development itself. And this is what a lot of what Chinese has been doing. So in this, the absorption, we call it advanced imitation itself. And the Chinese have been extremely good at absorption, and then what they do is like from absorption, how you turn it into output. The Chinese have the term which they call re-innovation. So re-innovation is basically having a foreign product and then improving upon it or rebranding it into an actual output. And we see this like what the Chinese have done with Russian fighter aircraft, like the Su-27, where they acquired it, they licensed, produced it, and then they developed their own version, which is called the J-11B, which is, it looks very much like a reverse engineered Su-27, and key parts of it are, but there's also put in a lot of domestic content itself. And you see this in many other areas itself. Even on the civilian side, Chinese high-speed trains are re-innovated products itself. So this is where the locus of innovation activities have been taking place. This is sort of the low-end style. Then, as a country gets increasingly better at this advanced imitation or advanced absorption, they then begin to they cross over into this into actual innovation itself. What you do is that you get a lot of joint development products that are taking place, and a lot of these official transfers that allows Chinese companies then to begin to establish a firm foundation. Then they improve upon that. So a good example of a crossover innovation is what they're doing in the aviation sector, like their commercial aircraft, the C919, that's been produced out of Shanghai. Much of the materials, I think the statistics are like 70% of the C919 comes from components and technologies that the Chinese have been able to acquire legitimately. They've signed agreements for that, for these transfers, and the Chinese basically they build the fuselage, and all the avionics, the engines, and everything inside are acquired. But the Chinese earn what they call the intellectual property rights to this, and so they build this, and then the generations as you go over are Chinese produced. So the follow-on versions of the C919 are Chinese products itself. And so this is the crossover innovation. And once you get that, you can get which is the incremental innovation, which is the standard model of how innovation takes place itself. Most innovations are incremental. So you build a version A, and then after a few years you build a version B, and you improve upon that itself. And this is by far the vast majority of what innovation is. Disruptive innovation, breakthrough innovations are a very, very small part of the high-end stuff. So much of this is where the locus of this Chinese innovation taking place. And then you move up, and in the innovation literature, you have things like architectural innovation, which is like a lot of the technologies are existing, have been around, but the way that you employ it, the way that you a market or apply military strategy to it, it has a significant impact. It changes things. So one of the best examples of an architectural innovation is, I would say, is Apple, right? Apple, a lot of the technologies have been around for quite some time, but Apple transforms those technologies, and they significantly adds new design features, new business models, especially with iTunes, for example, all the apps, and what comes out becomes a revolutionary product itself. And the best example in the military sphere on China is the anti-ship ballistic missile, right? The anti-ship ballistic missile is a technology that's been around since the 1970s itself, and the Russians and the Soviets tried to do that, etc. But the Chinese employ that, and they've used that, and they marry that to their anti-access area denial capabilities, and they've turned a basic technology into something that's really of significant concern, especially to the US Navy, because it's focused on high quality targets itself. So this is the type of low cost, high reward technology, and you don't really need a very significant or advanced research and development base to apply that itself. From an architectural innovation, then there's component innovation, where it's you need to have increasingly a very sophisticated research and development base, because you need to develop the components. So the system may be unchanged, but it's you need things like advanced jet engines, right, or semiconductors or avionics, etc., that fits into it, into the platforms to improve on that innovation itself, and that's what component innovation is. And that and the Chinese have made much slower progress, because architectural innovation is much more in terms of concepts and processes and approaches itself, while component innovation requires the hard inputs itself. And when you marry both the component and the architectural innovation, you get sort of the disruptive innovation or the breakthrough innovation, which is the very high end. And in these areas, the Chinese are not there yet. They're making progress, and that's the the key focus that they're having. So this is a useful typology. So when I go forwards, you can sort of begin to understand which parts or what types of innovation are we talking about. And if not, it's you can take a nap for the rest of the presentation. So the Chinese, so that's the typology. I mean, from a Chinese official point of view, they have a free prone innovation strategy itself. So this is the Chinese definition of their innovation typology. They have re-innovation. This is the advanced imitation, and this is and they have a specific term that I'll go into called IEDA: introduce, digest, absorb, and re-innovate. And this is where they are now itself. Now they move into the integrated innovation, the Jicheng Chuangjing, which is the best example of integrated innovation is sort of what companies such as the Japanese companies such as Toyota did in the late 80s. A lot of this in the automobile and the aviation sectors, where in innovation in the past, or especially in China in the past, and also still currently, it's a lot of the research and development has been very compartmentalized. So you have your researchers and your designers, they stay in their silos. There's little interaction with the manufacturers. or the marketing department. So they all do their own things in these vertically integrated silos, and at the end they somehow get together and try to sell their products. I mean, what Toyota and some of the aerospace manufacturers learned especially in the 80s and 90s, like you need to integrate all these different facets of the development and production processes. And so what Toyota or what the Defense Department did with these integrated technology management projects, etc., is that the manufacturing teams got together with the research teams, got together with the design teams, as well as the marketing, to meet at very early stages to be able to say, it's like, I mean, how do we do these things together? And in the end, what this leads to is a much more sophisticated and much more rapid pace of technology development. And so with Toyota, this is one of the reasons why they managed to get to become a world-class company. And the Chinese looked at that and they said, we really want to do this too. And this is very important also for defense research and development, because historically, and even right up to today, the structure of how the Chinese defense science and technology system was established and functions was based upon the Soviet Union. So when the Chinese defense industry first was established in the early 1990s, it copied lock, stock and barrel the Soviet model of the defense development, which is these vertically integrated silos. And I remember when I was doing this research, you have there was one interesting research report where it's this defense factory, one day it gets this blueprint of a fighter aircraft, and the blueprint comes from a ministry in Beijing, and the ministry says, now you have to produce this itself, and the manufacturer says, so we just got this, we have no idea how the design came from. It's how does these all things work, and which design lab or research laboratory institute did this, and the ministry says, you don't have to worry about that. We're your central link itself. And the research institute, they designed and they developed this, but they said, we have no interest in manufacturing. That's another organization. So what you had was this vertically integrated structure with a government entity that really is a bureaucratic entity. They are the transmission mechanism to this production facility. So you have a compartmentalized, fragmented structure. As anyone knows, I mean, innovation, especially advanced innovation, you need to have close coordination. You need to have horizontal linkages, and if you don't have that, this back and forth, you have a really seriously compromised system. And China had that for a very long time, but in the last decade or so, they've actually moved increasingly to this horizontally integrated structure itself. A lot of the big defense firms now, they've acquired a lot of the research institutes and integrated that itself. And so this is what that's about itself. And at the end, this is the third model of innovation, is what the Chinese call the original innovation. This is sort of homegrown indigenous innovation, especially at the high end itself. And original innovation has been very much something for the Chinese authorities, both in the defense and the civilian sectors, to aspire to. I mean, this term, this typology sort of came out in the mid-2000s when the Chinese authorities first decided that they wanted to be a world-class innovation power. So they came out with this long-term development plan called the Medium and Long-Term Chinese Science and Technology Development Strategy that came up in 2006, and to chart China's science and technology defense national and defense innovation to the year 2020 itself. And so this is a plan. And interestingly, and I'll go into this as we go forward, in the last year or so, they've come out with sort of a new strategy. So, so this was for, and the focus on the new strategy, which is what Xi Jinping has defined as a key part of the search for a new economic development model for China, is what they call a innovation-orientated development strategy, and that increasingly has its emphasis now is on original innovation itself. So re-innovation, they say, we've got that, we've ticked the box, and we'll continue to do that, but we're now looking to reorganize our science and technology apparatus, both on the national side as well as the defense side, to focus much, much more on these higher tiers of innovation. Any questions? No? Does this all make sense? That's good. Okay, sorry. Okay. So when we look at how innovation works, I mean, there's various different factors, and at the Air Power Conference, I gave one way to look at it itself in terms of sorting out between catalytic, input, process, and institutional factors itself. To confuse the people who were at the conference yesterday, I'm going to use a different way itself, and I'm going to sort out generally two types of innovation factors to look at itself. That gives you a holistic approach. One is what we call hard innovation factors itself. So those are the factors. So if you're looking, for example, if you're a defense analyst or intelligence analyst looking at how a country engages in innovation, one of the ways you do it is through looking at hard innovation contributions, which are also like what it's tangible, and those types of more input-related factors that you can count on, like how big is the research and development budget, how big and how well qualified is your work, is the human capital base of that science and technology apparatus, how profitable and how large are the defense companies involved. So all these things that you can count, and this is often what most people focus upon. It's like, well, when you look at the at China's efforts at science and technology development, you count how large their research and development is as a share of their GDP. For example, how many PhDs are there, etc. How many universities do they have? And that's very important. But that sort of gives you one picture. The other part of that we should pay attention to is what we call soft innovation capabilities. And these are sort of like the more intangible, process-related approaches. And this is sort of like things like what's the nature of the governance regime itself, because that's extremely important. One example is, do they have strong intellectual property protections itself? Do they have clear rules and regulations itself? And other intangible factors is what is the nature of the innovation culture? One important question, for example, is how do the Chinese think about and organize about risk, right? Risk is central to innovation. And if you have a system that is extremely risk adverse itself, your ability to engage in innovation is much more difficult itself. So it's like, and other things. I mean, another couple of very important soft innovation is like, how much leadership support do you have for innovation? If you have very strong, very sustained leadership support from the very top, then this helps you to overcome a lot of the barriers to innovation, etc. And the threat environment. Do you have a benign threat environment, which means that you don't get as much push to engage in higher end innovation. But if you have a high threat environment and the leadership tells the research and development organization, you can do whatever you need, but we need you to develop these types of products because we have an existential threat. That has a very significant impact itself.
I have one question. Is for you, like, is innovation fulfilled, or do we have it when it is possible to, or it is developed and possible to produce, or when it is integrated into the armed forces? Like, because that is still a long way normally.
Right. Yeah. So I mean, so that's a very good question. I mean, it's like so there's you can measure this in different ways. It's like I mean, a key part of innovation, right, as we in the literature, is the ability to diffuse and disseminate and make sure that it's actually adopted itself. A lot of the innovations, if they're in the research and development, and they never cross over into what in the innovation called the valley of death. That's like that's innovation, but it's like but it's unrealized innovation. So you really need to look at it as like that it gets to be adopted itself. So one of the big problems for the Chinese defense industry, up even to today, although it's not quite clear, is that their rates of what they call commercialization, their rates were about between 10 to 20%, which was extremely low. So they spent a lot on research, a lot on development, but they found out it's like that they never really managed to get the bulk of their products into actual output itself. So there was extreme waste and inefficiency. That still seems to be a major problem itself, but they're trying to change that effort now itself. And increasingly, what we see is that we see a pipeline of products and platforms that are beginning to be manufactured and being adopted by the end users itself. But this is a very, very important part of the structural problems that the Chinese have faced. So these are all the hard innovation indicators. And if I didn't have to catch the plane at 8 p.m., I would go and discuss every single one of these. So, and this is sort of the soft innovation things that I've talked about, like leadership support, threat environments, like the nature of dynamics. Is it technology push, demand pull, those types of things, etc. So those are the different types. So what I'm going to do is to talk about what I think are several of the most important factors itself: the high level leadership attention, the threat environment, some of the policy initiatives that they've taken place, and technology transfers and absorption. And I'll go